Diagram shows a line segment AB on the coordinate plane. A is the point 3, 2. 3 across 2 up. B is the point 9 across 4 up. Is that okay with you guys?
Yeah.
9 and 4, 3 and 2. Alright. Happy days, 9, 4, 3, 2. Okay. Using a compass, a straight edge and a compass, construct a perpendicular bisector of AB. Now, a perpendicular means you got to draw this new line at 90 degrees compared to the old line. Bisector means, bi means 2, basically half. You're going to be halfway in. Alright? Now, here's the way you do this. You get yourself a compass. Okay, and this is one of the many constructions on the course. We haven't actually spent time doing this yet, so you're not expected to know it, but we'll do it for argument's sake. You go above halfway. Yeah. Any distance above halfway. Generally speaking, not too far above halfway is better. And you draw like an arc. See this arc? Okay. So you draw this good old arc here. Okay. Then you go to the other sides. Keeping exactly the same distance you used on your first arc, you do a second arc. Now see where the two of them join each other? You put a line through the middle. Wait, yeah, I get it. Give me a second. And all of a sudden, what you have, the black line is perpendicular to AB and crosses through the midpoint of AB. The midpoint of AB is 6, 3. Is that okay with you, lads? Yeah. Alright. Sorry that question slipped by me. That.
Black line has to be a little bit longer though. 6, 4.
You what?
I got 6, 3.
Has to go up to 6, 5, sorry.
You did a midpoint for me.
No, it's definitely 6, 3.
No, it is 6, 3, but I'm saying that black line needs to be longer for a later question.
Oh, does it?
Yeah.
Okay, thanks. So you can make the black line, you can extend the black line beyond both directions, and that will work for a later on question. Thank you, Connor. Now, done. Find the midpoint and mark it on the diagram. We already did that, didn't we? 6, 3. You could also find the midpoint using what formula? Yeah. How many is I suppose if some of you are stuck, you could have done this, couldn't you? What's the slope of this line? Lads, I'm going to show you a trick here, right? You should be aware of this trick. Does everybody agree that the slope is 3 across 1 up?
Yeah.
And what is the slope of 3 across 1 up?
3 over 1.
No, opposite. What's perpendicular to 1 over 3?
Minus 3 over 1.
Now, what minus 3 over 1 is, believe it or not, would be something like this. What minus 3 over 1 is, down 3 across 1. And I could actually link my midpoints to this point and actually make the perpendicular bisector anyway, couldn't I? Now, I wouldn't get marks for it because it told me specifically to construct it. But you could still get the perpendicular bisector without constructing it, if you get what I'm saying. All you need to do is find 2 points and link them together. Just showing you a little trick, just in case you don't know that. Find the equation of a line. Anybody remember the equation of a line formula?
1 minus y1 equals m by x minus x1.
Okay. Quick question. What's m in reference to?
Slope.
Okay. And what is the slope of the black line?
3 over 1.
How did we get that earlier?
The slope of the AB turns to 1 over 1.
Yeah, you can turn the slope of your original line. So, several ways. You could do the slope formula for your original line. You see the original line? Yeah. So what's it? X2, Y2 and X1, Y1. And the slope of the original line would be this. Okay. And that will get you 4 minus 2 all over. And what's that get us? 2 over 6, which is? And then turn that upside down, change the sign, and you get minus 3, don't you? So the black line has a slope of minus 3. Okay? So it has a slope of minus 3, and what point does it go through? It goes through the midpoint, doesn't it? Yeah. Which is 6, 3. And many people have successfully got this done. I wouldn't say many of us. It's been a while since you did them, hasn't it?
Yeah.
So you're probably quite rusty. Did you use the solutions much? The examnet codes and stuff? You might have to. It's alright. And we got 3x plus y equals 21. Alright. Lads, how do you verify that 5, 6 is on the line? Now, it's quite obvious on your diagram. It's quite obvious on your diagram that 5, 6 is this point here. And that point there is on your line. John, how would you verify it's on the line without actually drawing the line?
That you put back into the. So where is the midpoint now?
Verify that 5, 6 is on this line here.
Oh, you put it back in the same.
Yeah, sub it in. If it balances, it's on the line. So what do we think? 3 times 5 plus equals? Yeah, 21 equals 21 on the line, yeah? Yeah, this is a hefty question, right? How's it going?
We did a joint test with our classes on patterns and sequences.
Alright. Now lads, shh. Are we all good with that? Alrighty. Now, next question. F. What do those two vertical lines mean again?
They're equal.
Shh.
In length.
Lads, it means the length AM and AP. Now when you see these values, what is the usual formula that comes to mind? Anybody know? There's something called the distance formula. Okay? Now, here's what I need to know to use this. What is the point A? Can somebody tell me what the point A is? What's the point M?
6, 3.
Alright, here's what we're going to do. Right. So, x2, y2, x1, y1. Does it matter which one you call x1, y1, and which one you call x2, y2?
No.
This is point 1, this is point 2. Somebody else could say that's point 1 and that's point 2. It's okay, it works out. The main thing is the x's are on the left and the y's are on the right. Now what are we going to get here, lads? 6 take away 3 squared, and then what else?
3 minus 2 squared.
And you get square root of
3 squared plus 1 squared.
square root of 10.
Yeah.
Is that alright, square root of 10? Now, could somebody tell me what the letter P is? P.
5, 6.
P is 5, 6. And we're going to go through the exact same procedure, okay? And this time it's going to be, we call, what?
5 minus 3 squared.
Yeah, 5 minus 3 squared and
6 minus 2 squared.
and what you get for that, Connor?
2 to power 5.
2 root 5.
Yeah. Sorry. Oh, yeah, 2 root 5 squared. Oh, I said power.
Yeah. 2 root 5. Is that alright?
Yeah.
Now, if you go back to your original diagram, okay? Root 10 and 2 root 5. Okay, now, just give me a sec. Just going to make it a bit less cluttered. Alright, now, which one's P? That one's P, is it? Okay, and what two distances did we get last time?
AM and AP.
So we got AM and AP. So here's what they want from us. And this will finish off this really quickly, okay? What angle did they want from us? What angle did they want, lads? It says in the question. Angle what? A what? PAB. They want this angle here. Let's call it X for argument's sake. What do we know about the distance A to M? What do we know the distance of M to P? Or sorry, A to P? 2 root 5. Stay there, lads. What function should you use? Sine, cos, or tan? Now, for those who don't remember, opposite is this side, we don't know it. We know the adjacent and the hypotenuse, which means we're using cos x equals root 10 divided by 2 root 5. Go into your calculator and press cos inverse. And then you get root 10 divided by 2 root 5. And you get a 45 degree angle. Who got 45 degrees? Excellent. What page?